Perfect. All right, so welcome everyone. Today we're going to be going over the basics of JavaScript. Connor also just posted in the chat our script that has all the materials kind of written out. My goal for today is just kind of introduce all the concepts of JavaScript. You're not really going to be able to know everything without practicing it, and it's going to be a lot of information. So just having that script alongside it is going to help you just be able to see things and process them. Since it's a lot of material, we're going to go fairly quick through things. So if you might not catch everything, but dive into it. I'm also going to be asking you guys a lot of questions throughout this. So please just answer me in the chat, or we're just going to be sitting in silence for a while, and that'll be a little awkward. So what is JavaScript? Essentially, it's the primary programming language that websites use. Oh, there we go. Yeah, so it was originally developed around the year 2000. It was mostly used for kind of like small website scripting things, but since then it's kind of grown into a very, very popular language that kind of takes over all elements of web development. And just as a little disclaimer, if you guys did the Java Course Academy or Code Academy and learned from that, JavaScript and Java have the same name and some of the same syntax, but don't have a lot in common otherwise. So it's going to be very different. But all the concepts of a programming language are pretty similar. So we'll see the differences in there. So just where can you write JavaScript? So you can actually do it in your browser. If anyone's using Chrome, you can click like the little dot thing and just go to your developer tools. They have a console built into, they have a JavaScript console built into your browser. You can also use any online code editor. We listed 3 of our favorites there. And then just any file with like a .js extension on your computer if you want to develop locally. And we'll see as we get into React more kind of JavaScript stuff. So just a couple basics. Going to be showing you guys a lot of code throughout this. Again, all the same examples are going to be written down in the script. So if you miss something, don't worry about like keeping track of it. I just want you guys to get the idea of what this code looks like and what you can do with it. So a very basic command that we're going to use is console log. So all that's going to do is just print out a string or a value anywhere. And I also just want to make you guys aware of comments. So comments can be either with a double // and that'll just comment out the rest of the line, or you can use this /* syntax. Just see if I can, yeah. So you can just use this /* syntax to comment out a whole block of code. So the first thing we're going to talk about are variables. And if you haven't used a programming language before, this might be a little bit new to you, but I'm hoping most of you kind of have some idea what variables are. Essentially, there's a way to reference data by a name. And unlike Java, if you are familiar with that, JavaScript is completely untyped, which means when you define a variable, you assign a value, you don't have to say what that JavaScript is just going to try and figure that out based on the actual value. So that's kind of nice. It saves us some time of having to work with things. It's very flexible. It will cause some issues in certain cases, and we'll look at that later on. But all you have to know is we have 2 keywords, let and const. You should use let whenever you're using a variable that you think would get reassigned. You'd never have to use that equal sign more than once, and use const. And you can define them and give them a value in separate lines. So we see for unassigned var, or you can just do it in the same line. So we talked about variables, but what's the actual data that we can assign to variables? So a lot of different data types that we can use, including numbers, strings, booleans, arrays, objects, and a couple special values like null and undefined. We're going to walk through each of these one by one. And again, feel free to use that reference as we're going through things. I don't expect you guys to catch everything on the first pass. So the first data type that we're talking about is numbers. JavaScript's pretty easy with numbers. They let you do kind of all the intuitive things you would expect. You just type them in. You can use addition, subtraction, multiplication, division. You can get negative numbers by putting a minus sign in front of them. And you use decimals, all fine, and JavaScript just makes things work. The next thing we'll talk about is strings. And if you haven't seen strings before, essentially they're just an ordered collection of characters, where a character is just a letter or a white space or some kind of like a exclamation mark, whatever those are called. JavaScript, we can define strings either with double quotes or single quotes. And we can also combine strings using the addition sign. So like we said, strings are just a list of characters. Because of that, JavaScript gives you some ways of kind of interacting with it like a list. So you can get the length of a string by calling .length on it. We can see that down here. We can also access the characters in a string by their index, which just means their position in the string. An important thing to note about that is JavaScript is zero indexed. That means the very first element in a string, like the very first character, has an index of 0. It doesn't start at 1, it starts at 0, which means it goes all the way up to the length of the string minus 1 is the last index. And we'll also just show that you can get like a substring of your string by calling .substring with a start index and an end index. There's a lot more functions built into strings, but we're only showing these ones. Again, in the script, there are references to a full list of these different functions. But just know there's a lot more things that you can do. So you can see down here in the code example, we have our string length, which if we count here, it's 1, 2, 3, 4, 5. You do count the white space, so that's 6, 7, 8, 9, 10, 11, 12. So the string length is 12. Letter H, like we said, is the very first letter and has a 0 index. We get the very last character, which is the exclamation mark with the length minus 1. And we can just crop out the hello by getting a substring from 0 to 5. Important thing to note is with substring, the 0, this index, the first one, is inclusive, meaning it's going to include the character at this index, but the last one is exclusive, which means it will disregard that space. So the space is the 5th index. We don't actually get the space in our hello string. So let's make sure you guys are awake. So who can tell me what A, B, and C are equal to? Just take a second. If you guys can answer in the chat, that would be perfect. Give you guys a second. No guesses?
Check the chat.
We got some 14s. E. C is E space. Yep, so again, our length we can just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Looks like everyone kind of got that one. So A is 14. B is the 5th index. So again, we start at 0, 1, 2, 3, 4, 5. So it's E. And then C is from 5 to 7. So we take the E, we take the space, we are excluding the 7th index, which is the C. So we get E space. Good job on that one. All right. So the next data type we're going to talk about are Booleans. And Booleans are really just the value false or the value true. Yeah. So it's basically, we can only have false, we can only have true, and combine Booleans with different operators. So I'm just showing a couple standard ones here. we can take the or of two booleans, which means we get true back if either boolean is true. We can take the and, where both of the booleans have to be true to get back true. And we take not, which is just the opposite value of the boolean. So we have some examples here. I won't ask you guys to fill out all of them, but we'll just work through it together. So this first one, we're using an or. One of them is true, so or one is going to be true. Or two, we can see we're combining multiple operators here, but they're all false, so or two is going to be false. And one, we have two trues here, which this part is true, but because we have one false, the whole expression is going to be false. And two has two trues, we get true. Not, the not of a true is a false. And who can tell me what this combination is going to turn out to be? Any guesses? Do we have anything in the chat?
Yep, got a couple trues from Andrew, Nick, Baden, Julie, and Leroy.
There we go. Yeah, it is true. We can see this comes out to false, but it's an or, and then this expression is true. Sorry, I can't actually see the chat because my other browser is killing itself. But great, let's move on. So the next type we're going to talk about is arrays, and arrays are just an ordered list of data. So we can see they're wrapped in this bracket, and they can hold any other kind of data. Again, just like strings, we can refer to elements in the array by its index. We're still zero index, the first element is still zero. We can also get the length of an array with dot length, again, just like strings. And then we can also reassign elements in an array, which isn't on this example, but we'll see it on the next slide. So just from this code example, things you should note, we can have arrays nested in other arrays. The data types don't matter at all. You can have whatever you want in it. If you have one of these nested elements, you can refer to it by doing two brackets in a row. So R3 is the third index, which is our second array. And then the first element is A. So nested L is equal to A. And just like the strings, we can get the last element with the length -1. All right, here's another question for you guys. Can you tell me what A, B, C, and D are equal to? Also take note of the assignment syntax here. We're just saying the first index is going to be equal to bat. I'll give you guys a minute. Again, I can't see the chat, so can someone let me know? Or you can even see your answers if you want to unmute yourself. Any guesses?
Yeah. Oh, one popped up. A couple are popping up. We have A is 4, B is an array containing A and B, C is, I see some different answers for cat and 1 for C, and then D is bat.
Yep, so generally that sounds about right. The only tricky thing here is C is going to be equal to cat because it's equal to cat here, but then we change it, and now it's equal to bat. But pretty standard. All right, the next thing we're going to talk about is objects. And objects are defined as a list of key value properties that are wrapped in these curly brackets instead of the square brackets like arrays. And the values of objects can be any other type of data. So essentially we can see in our example over here, the keys are just going to be just plain words, not wrapped in any quotes, just up here. For our purposes, all these keys should only be a single word, and then we can then use that key to refer to the value that it is pointing to. Just a couple things to note about the syntax here. There's going to be this colon value separating our key from our value. We always include a comma at the end of our property unless we're at the end of our object and there are no more values. And then just like arrays, we can nest objects inside of each other. So here we can see once we have an object, we can refer to it in two different ways. The first is by just calling the object dot the key name. So we can see person name is person dot name. Or we can use the same bracket syntax, which is kind of like accessing an index and array, but instead of giving a number, you give a string that is the name of the key. So here we're getting age. We can also see if we try to access something that doesn't exist, we'll get an undefined value. So right here, person weight, we can see our person doesn't actually have a weight defined. So this value is going to be equal to undefined, which is a special type that we're going to talk about in just a second. But then just like arrays, we can also set up keys after we have our objects. So we can say person.weight equals 150. And now when we get the new weight using our other syntax, new weight will now be equal to 150. And the last two types of data that we're going to talk about are null and undefined. So these are just special types of data that JavaScript provides for us for special use cases. And I want to make sure you guys are kind of aware of them, but generally you really shouldn't be using them as like part of your code design. Generally, if you see these values popping up, it's usually a good sign that something went wrong in your program. It's not always going to be the case, but as you're learning JavaScript, the good rule is just try to avoid them as much as possible. You can see undefined is just when we have a variable, but we don't actually give it a value yet. It'll just start off as undefined. All right, so take a breath. Those are all of our data types. We covered a lot of material there. Again, we went over numbers, strings, booleans, arrays, objects, and then also our special types, null and undefined. And if you guys have any questions, again, feel free to ask them in the chat. Connor will be looking over and is available to answer anything. But all right, let's move on. Let's talk about control flow. So control flow is basically a way that lets us execute a block of code only if a certain condition is met. And conditions are just expressions that evaluate to booleans. And then since we're not always going to be working directly with booleans, we can use comparison operators to get a boolean by comparing two different types of data. So basically control flow is all the interesting things that you can do with programming that makes it really, gives it a lot of its power. So let's first look at a couple of these comparison operators since we're going to use them in a lot of the different control flow loops that we use. So this is where we come back to that issue of JavaScript not having types defined. So because of that, there are actually two different types of equality in JavaScript. There is the double equals and the triple equals. So here we're saying 5 triple equals 5, and that's going to be true. And essentially the difference between the two of them is if you're using double equals, JavaScript's going to try and convert the two values into the same type before comparing them. So we can see down here with E, we say 5 equals to 5, but 5 is a string. And this is still going to return true because before JavaScript checks if these two values are the same, it's going to turn them both into the same type. You get some weird problems that pop up because of this, where the way JavaScript turns them into types can sometimes be unexpected. We're not going to go super in depth with it, but just kind of know that this can pop up and it is a source of bugs sometimes. And then we also have the inverse of equality with our exclamation equals, which means not equals or not triple equals. And then we can also do the standard less than or equal to, greater than, and greater than or equal to. So here's another test for you guys. We have a lot of letters this time. So maybe you can enter them in the chat as you get each of these letters. But I'll give you guys a second and we'll see if you guys can figure this out. Yeah, see, we had a question about the triple equals in the null slide. I hope now you know.
Another question popped up from Satwik, which is, which type does it convert when you use double equals, like the one on the left or the one on the right? I actually have no idea. I'm not a huge JavaScript person myself. So Liam, would you know?
So it's a great question, and it's one that I purposely avoided answering because a lot of the time it's going to be a little indeterminate with there. And you can look up the exact rules and kind of work it out. Generally, if you have to worry about that, it's a sign that your program is not very reliable. So try to avoid ever having to kind of know exactly what type things are going into. If you can use triple equals, you always should. You don't want to use double equals if you can avoid it. And generally, it's not a great idea to be working with data of different types if you can't avoid that either. So do we have any answers for what these variables are going to come out to? Anyone brave enough to venture a guess? Oh, yeah. Got some answers coming in.
Yeah. So it looks like
It's okay,
A is
Tony,
false.
we can work through it together.
Got it.
So A, different types, same value though, because it's the double equals and the double not equals. This is going to be false because these are the same value without the same type. With B, now we require that they have the same type and they aren't the same type. So this does come out to true. So B is true, A is false. C, when we compare them, 5 and 5, they're the exact same string, so that is true. But D, this one's a little bit tricky. JavaScript's not going to change words into numbers, so this is going to be false. The double equals will only convert it if it's the exact same value. It's not going to do anything super weird like this. So D is false. E, 10.5 is indeed bigger than 10. 10 is not less than 10 because it's exactly equal, but it is less than or equal to 10. So F is false, G is true, and E is also true. But awesome. So let's start looking at some control flow that we can do. So the most basic one that we can use is kind of the if-else statement. So what that'll do is you can define a block of code that you want to run only if a condition is met. You can also then combine that with, if this condition is not true, doing something in the else block. And then you can also use intermediate else if statements here. So I think it becomes a lot easier to work with once you kind of see a couple more of them. Say if condition 1, we're going to console log first path, else if condition 1 is not true and condition 2 is true, then we're going to console log second path. Otherwise, if both of these are not true, we're going to print out the third path. So we can see up here, condition 1 is false, condition 2 is true. We're going to be printing out second path. So the next type of control flow we're going to talk about is while. And while is similar to if, but it will continuously run that code block as long as the condition stays true. So down here we can say we're defining a variable called counter, and we're going to set it to 0. We're going to say while the counter is less than 4, we're going to run this block of code, which is going to print out the value of counter, and then also add 1 to counter. So who can tell me how many times this is going to run?
Is it 4 times?
It is 4 times. Good answer. So you can walk through it if you want, where counter is going to start at 0 right now. So we're going to print out 0, add 1. It's still less than 4, so we'll print out 1, add 1. Now we have 2. 2 is less than 4, so on. Once we get to 3, we'll print out 3. We're going to add 1, so now it is equal to 4. And now this condition is false, so we're going to break out of the loop, and our code will start right over here. So just be aware that your condition, every time your code executes, it should be updated. So if we didn't have this line right here that added 1 to our counter, and counter just stayed at 0, we'd have what's called an infinite loop. And essentially it's just going to crash your program once your computer runs out of space. Just keep printing out zeros millions and millions of times. All right, so now we're going to talk about for loops, which is one of the more complex loops that we have. Also the last one of them. And essentially for loops are just a shorthand for while loops. So you can do everything with a for loop. You can do everything that a for loop does with a while loop, but just makes it a little bit easier to do certain things for common use cases. So a for loop has these 3 parts to it: a declaration, a condition, and an action. So we'll look at this example down here. The declaration is something that's going to be run once before anything in the loop happens. So here we can say we're defining a variable called I. We're going to set it to equal to 0. The condition is just the same as that while the while loop condition. It's just something that's going to be checked every time. If it's true, the code will run. If it's false, then the code is going to break out of the loop and start down here. And then the last part is an action. And an action is going to happen once at the end of every loop. So you can see our while loop kind of has the same parts here. It has a declaration of setting the counter to 0, it has a condition checking if it's less than 4, and its action is down here of adding 1 to the counter. But the for loop just condenses everything. So for I equals 0, while I is less than 8, and incrementing I by 1 every time, the code will run. How many times is this code going to run? I see someone asked about the increment operator. It is there. I'm just not using it since I'm giving you guys enough information. I don't want to overload anything. Any guesses on how many times this code is going to run? It's an easy one. Eight times, exactly. All right, so this is a challenging one. I made this tricky on purpose because I want to show that not all these for loops don't have to be very simple, and we don't have to do it together. But we can see we still have our declaration. We have I equals to 1. I forgot the let keyword here. Just know that there should be a let I equal to 1. So ignore that. Our condition Now where it's going to be more complex, we're going to say if I is not equal to 32 and j, which is our different variable up here, is not equal to I, then our condition is going to run. And every time we're going to multiply I by 2. In our actual code block, then we're going to divide j by 2, and we're going to print out this console log. I'll give you guys a minute. I want to see if people can get this one. It's a little tricky, I know. But what is going to be printed out of the console? Can anyone give me the first thing that's going to be printed out to the console? That might be an easier start. I equals 1, j equals 64. That is correct. And let's just walk through it together, since I don't want to stress you guys out too much. But we're going to say at the beginning of our loop, I is equal to 1. We already have j equal to 128 outside of it. We'll divide j by 2, so now j is equal to 64. So here we're going to print I is 1, j is 64. The loop ends, so we're going to do our action. We're going to multiply I by 2, so now I is equal to 2. We go to the beginning of the loop. J is still equal to 64. We divide it by 2. Now j is 32. So the second thing that's going to be printed is I equals 2 and j equals 32. Loop ends, action happens, I is now 4. J gets cut in half again, so now it's 16. Our condition is still true because I is not equal to 32 and j is not equal to I. So we're going to print out I is equal to 4, j is equal to 16. Our loop ends, I times 2. I is now equal to 8, which is not 32. J is 16, which is not equal to I either. And we're going to cut j in half again. So now I is 8, j is 4, right? So we'll print out I is equal to 4, j is equal to 8. We multiply I by 2, so now I is equal to 8. And we check our condition. I is not equal to 32, but now j is equal to I. So this whole expression is false, and we're going to break out of our loop. So it's a confusing one. I just wanted to show you guys that these for loops, like a lot of times you'll see them pretty standard, but you can really put anything you want for your declaration, condition, and your action. So along with that, like we said, for loops are really just a way of kind of making our lives easier when working with whiles. It's just a shorthand for a while loop, really. And then along with that, some common use cases that we're going to use for loops for is either iterating all the elements of an array or the keys of an object. And for loops also have a built-in syntax for that. So if you have an array down here, we can say for the element of an array, we're going to print out the element. So we use this of keyword here. So this for loop is just going to run once for every element in our array. So we're going to print out 1, 2, and 3. We can do the same thing with objects using the in keyword. Say for the const in this object, we're going to print out the key. Important thing to note, when we're using for in loops, we're iterating over the key values. So we're printing out key 1 and key 2. if we wanted to get the actual value from these keys, we would have to access it from the object with our key in our for loop. We'll see a little bit of that later on, I believe, which is good things to keep in mind. And the last thing we're going to talk about in regards to control loop or control flow is continue and break. And basically these are keywords that allow you to change the behavior of loops. So continue is going to jump to the next loop of the code block, and break is going to immediately end the loop regardless of the condition. So if we're going through our for loop and we hit a continue, we're going to skip everything else in the block, go back up to here, execute our action, and continue in the next loop. If we ever hit a break keyword, then we're immediately going to forget about all this code and immediately jump to right here, right after the loop. So here we go, more for loops. Who can tell me what gets printed? Keep in mind our conditions are checking if I is equal to 2 or I is equal to 4. We're going to continue. And if it's equal to 6, we're just going to break and stop everything. Take some time, study it. Zero, 1, 3, 5, exactly. For 2 and 4, we continue, so we never get to the console log. Once we get to 6, we're breaking, so we're not going to execute any more of them. So 0, 1, 3, 5 is correct. So just a little bit of a recap. This was control flow. We have our comparators that help us compare different types of data. If-else statements let us run a block of code once if condition is met. While loops let us continuously run a block of code while a condition remains true. And for loops are just saving us time when writing while loops with a special syntax. And then we also have our continue and break keywords that let us change the execution of a code block while in a loop. So just a thing to note, continue and break works for while and for loops. You can use them either. All right, take another breath. We're moving on to functions. And if things weren't complicated enough, here's where it gets a little bit confusing. So again, don't feel bad if you don't get everything on the first pass. That's why we have these materials, and that's why we have these assignments that'll kind of help you get more familiar with JavaScript. All right. So all functions are just named blocks of code that we can reuse. Along with that, functions can take 0 or more arguments and return up to a single value. Sometimes functions don't return anything, but they can return one thing or 0 things, and they can take as many arguments as they want or none at all. Along with that, the return keyword tells us what we want to return from a function, and functions can be called with the parentheses, kind of wrapping the things that you want to give as arguments. So we can see down here, we're declaring our function. We use the function keyword. We give our function a name, it's called our function name. We're saying for our function name, we're taking 2 arguments called argument 1 and argument 2. And then in here, we're going to define a variable called sum that is just argument 1 plus argument 2. And we'll return sum. So down here, when we call our function, we just give the function name, our function name. And then here we're going to pass 4.2 is going to be equal to argument 1, and 6.4 is going to be equal to argument 2. So now function value is going to equal to 10.6. So I know we finished talking about data types, but in JavaScript, functions are very similar to other types of data. We can do a lot of the same things. We can assign functions to variables. We can pass functions as arguments to other functions. We can also return functions from other functions. And we can store functions in arrays or as the values in objects. So essentially what I'm talking about here is down here, we're defining this function called console print. It's just going to print out whatever argument we're given. We can then set a variable equal to console print. And note that there's no parentheses here. We don't have a parentheses, so we're not actually executing console print on this line. We're just saying standard print is another name referring to console print. And then we can use standard print as if it was the original function. So you can say standard print, this still gets printed. And it does still get printed. So this is something that's, especially if you're like familiar with Java, it can be kind of confusing to work with, but it's a really powerful idea, and it's one that we're going to use a lot in React. So it's a really important one to kind of wrap your head around. So we're going to look at some examples just to hopefully make things a little bit more clear. So right here, again, we have a function just called adder, just adding our two numbers together. Once again, we are setting a variable adderfunc, which is equal to adder. No, we just have a little code block here saying we're not using the parentheses, so nothing's actually being added yet. We then define a new function called array combiner. An array combiner is going to take an array and a combiner func, which is just a combiner function. Thing to note, these can be named, your function like argument names can be named everything. It doesn't really matter. Yeah, so array combiner. We define a sum, and then we're going to use our for of loop here to iterate over every element in our array. And every time we do that, we're going to call combiner func with the sum and the element and return our sum at the end of this. So then down here, we can call array combiner with our number array and our adder func. So again, we're passing one function into a different function who's then using that to return some value. So we're passing 1, 2, 3, 4, 5. And because we're just adding the values together, array sum is going to equal 15 at the end of this. It's adding up every element in the number array. Like I said, we can also return functions from other functions, which again is just kind of like a weird thing to get used to. But we can see we have this function called getAdder. And getAdder is going to take two arguments, num1 and num2. And then we're going to return another function called adder, which takes no arguments and returns num1 plus num2. So an important thing to keep in mind with this is the idea of scope. So because adder is inside getAdder, it knows what the value of number one is, it knows what the value of number 2 is, and it can return them without taking its own arguments here. So down here, we're going to call getAdder with 3 and 4. At this point, this code hasn't been executed yet. The code that's been executed is the kind of outer thing. An adder function is now a pointer to a function. The actual addition itself does not happen until we call it with another parentheses. So now sum is going to be equal to 7 here. And we can kind of condense these two statements with this kind of double parentheses. So what we're saying is we're going to first execute the outer block, and then we're going to execute this inner adder function. So sum2 is going to equal 4. So an important concept to keep in mind here is at this point, adder function, this internal adder function is going to save the value of number 1 and number 2. So 3 and 4 are going to be saved here. We can't change it anymore. It's just the execution hasn't happened until we call this here. Now for something like just adding 2 numbers, there's really no reason why we would want to do something like this. But once we get into kind of more complex functions with React, kind of functions that have side effects that do different things, it's going to be a really powerful concept to be able to define these values beforehand and just save their execution until later. So this slide looks intimidating, but it's not actually that bad once we look at it. But we're just showing that functions can also be stored in arrays or in objects. So here we can see we have an array of functions that add 2 numbers, subtract 2 numbers, and multiply 2 numbers. We then have an object that has essentially the same things with an add key, a sub key, and a mult key. And then once we've done that, we're going to define a variable called answer and set it to 2. Then we're going to iterate over every function in our array and execute it and set answer to the new value. And then we'll do the same thing with the objects. Keep in mind, like we said, we're getting the keys. So we're getting add key, sub key, mult key. If we want the actual values of the function, we then have to address the keys using the square bracket syntax. So take a minute to digest this, and let's see if anyone can get what answer will be at the very end of this code block. Let me know if anything pops up in the chat. I think my window's frozen right now. No guesses?
Nothing yet. Oh, 24 just popped up.
Yeah, 24. Yeah, let's just let's run through it. Let answer. We're going to go through every function in the array. Just keep in mind that when we do this, it's going to be in order. We're going to execute each of these functions with the answer and the value 3. Now, something to keep in mind, because we have an addition and a subtraction, they kind of cancel out. So answer is going to be 2 plus 3 is 5. Then we're going to subtract 3, so we're back to 2. And then we're just going to multiply 3, and we'll have 6. Then we're going to do the same thing with all the objects. Again, we have an addition and a subtraction. So we have 6 plus 4, we get 10. 6 minus 4, back to 6. And then 6 times 4, we end up with 24 as our final answer. That is correct. So something to keep in mind there, we can see in this, we have all these functions that we're defining names, add, sub, mult, but then when it comes to actually using them, we never actually refer to this name of add or sub or mult. In fact, we don't even need that name at all. So what JavaScript does is it defines anonymous functions, which is basically another shorthand for us to kind of speed up things so we don't have to keep typing the same things over and over again. And basically what it'll do we get rid of this function keyword and we get rid of the name that we're defining. And instead, we just have this parentheses and then an arrow equals and then the greater than symbol pointing to a block of code. We can actually even, we can see we have that up here. We're defining two numbers that are going to do some stuff, but we can actually even simplify that further. If, for instance, we didn't have this line here and we just wanted to return like num1 plus num2, we can actually just omit those curly brackets and just point directly to the return statement. So we're going to see this syntax a lot. Again, in React, we're going to use these functions as data a lot of the time. So we'll see it a lot. So it's something to just keep in mind. It's fairly intuitive once you get a little bit used to it. It just saves us having to define all these function names that we're not going to use. And that was it. Can you imagine? That was our introduction to JavaScript. We have 2 minutes left on the hour. Again, don't worry if that just felt like very confusing. There were a lot of things going on. There's no way you're going to understand things right off the bat. So just using those materials, kind of reviewing things later, working on some JavaScript assignments is really going to help you just know this better and kind of get a hand of all the things that we're working with. And so just a sneak peek of next week. We're going to be doing an introduction to React. I've been saying that a lot of the time. It's basically just a JavaScript framework that most modern websites use. So it's going to be, we're moving on from HTML and CSS. It's going to have a lot of the same elements, but this is what most like modern websites are built on, either React or a different similar JavaScript framework. So thank you guys for sticking with me. You did it. If you wouldn't mind just filling out this feedback form to help us with this. I know this was a very dense lecture, but we want to make sure that you guys are getting the most out of it. So if you have any feedback, please fill out this link. And Sadaf or Connor, if you guys wouldn't mind just pasting them in the chat, that would be great.
Yep, I just sent it.
Perfect. But other than that, thank you guys for coming. We're going to be putting out all these materials along with our optional assignment for the week later today. So just keep an eye on the Slack channel. But thank you for coming in. Hope you learned something.